Greetings. In this podcast, we're going to talk about measurement, particularly how quantitative researchers observe characteristics, convert those to numbers that they can then analyze to come up with some assertions and hypotheses. So, by the end of this podcast, my goal is that you understand measurement in quantitative research, that you understand the differences between types of scales used in research, nominal, ordinal, interval, and ratio, as well as understanding the concepts of reliability and validity. To that end, we're going to focus on measurement overall and what measurement is, and then we're going to talk more about the scales and go in depth with both of those things. So let's begin with measurement. As I said before, quantitative research depends on the numerical report of observable data or variables. So they're looking at data or variables and thinking about how to report them via the use of numbers. They're quantifying something that's qualitative in this way. Now, in order to do this numerical report, quantitative researchers have to rely on scales, which are systematic assignments of numbers to identify the qualities of a variable. And when we're talking about scales, measurement scales, there are 4 different kinds. We've got, there we go, nominal scales, ordinal scales, interval scales, and ratio scales. We'll start with talking about nominal scales. And nominal scales are used to distinguish and designate subclasses of characteristics. In the literature, you may also see these called classificatory scales or dichotomous scales when only 2 characteristics are involved. So let's take a hypothetical example. Let's say, for instance, that in this hypothetical example, there is a study looking at the relationship of eye color to reading achievement. In this study, eye color would be coded as such. 1 equals brown, 2 equals hazel, 3 equals blue, 4 is silver, 5 is amber, and 6 is other. Now, what is important within these qualities that the researchers are observing is that there's really no power relationship among the variables, right? This is just a way to classify the colors of eyes that are out there. There's difference, but also equivalence. And what I mean by equivalence is within this coding scale, there's no hierarchy of what is better than anything else. So, brown is equal to hazel, is equal to blue, is equal to silver, is equal to amber, is equal to other. It's really just there to designate difference, categories of characteristics. Now, we're often going to find this within content analysis. So an example that I have is a study, a content analysis of gender representations in notable children's picture books. And what they've done is they've gone through the selection of children's picture books and they have measured it via this scale. 1 was female, 2 was male, 3 was both female and male, and then 4 was neutral. So they literally went through and they coded books based on this nominal scale. One wasn't more powerful than the other, one wasn't more important than the other. It was just a way to capture the difference within the books. So how that looks in the actual research is like this. And we can see in table 1, literally the female, male, neutral table where they've done this kind of coding. Now, the interesting thing about this particular study is they looked at both main characters of these books as well as representations and illustrations. And their illustrations are a little bit more in-depth and thorough. So they have categories of females only, males only, both, female animals only, male animals only, both, and neutral for a grand total. But both of these are really examples of nominal scales where within the data themselves, there isn't necessarily one being better than the other. It's merely a category of difference. Now, this slightly differs from an ordinal scale, in which an ordinal scale presents numerical relationships of characteristics at intervals that are unspecified. These are also known as ranked scales, and this is slightly above nominal scales, and we'll see that in a moment. So let's talk about a hypothetical example here as well. So we often see these in perceptional studies, right? Studies looking at students' perceptions of informational text. You would be responding to a survey item that would say, I really like reading informational text in my free time. 1, strongly agree, 2, agree, 3, neutral, 4, disagree, 5, strongly disagree. Now, what is interesting here is that when we're thinking about the interval or the distance between strongly agree and the distance between agree and neutral, we might assume that numerically or data-wise that they're all the same, but they're really not. There's no distinguished interval, right? Rather than having a true numerical value where strongly agree is the same distance away from agree as it is from neutral, as it is from disagree, as it is from strongly disagree, what this kind of scale does is it gives us a scale of order, right? From strongly agree to strongly disagree. There's an order of that. The distance between each of these points on this scale are unknown, right? But there is an order, and that's all that we're able to have. So, looking at this in some of the research, if you have a chance, McKenna and company has done a really interesting job over the course of the last 15 years looking at children's attitudes towards reading, and they've been developing these surveys. Their latest work is on adolescent surveys of reading attitudes and new literacies. And so you've possibly seen this attitude survey before, and what they've done is they've created these statements about reading, both reading for pleasure and reading for academics, and they've correlated them with Garfield. And you have really, really happy Garfield, and then you have really, really grumpy Garfield, right? And so when you go to score this, the ordinality of the scale that they're using really makes itself apparent in the key, right? Happy Garfield's worth 4 points, grumpy Garfield's worth 1 point, right? So when you go through and code these things, it becomes orderly. It's not necessarily that grumpy Garfield is the same distance from cool and suave Garfield, is the same distance away from Garfield who looks somewhat happy to the ecstatic Garfield. Those distances being equal and actually meaning something are all things that we assume. They aren't actually there, right? So really it's there to give order to some of these emotions that we have about these survey items and our reactions to them. So here's how this might look like represented in a chart. So in this particular figure, we're looking at recreational reading and academic reading and how it declines over the course of grade levels. And so they're providing some sense of how these attitudes change, and they're giving some order to it. So let's move on to interval scale. Now, when we're talking about an interval scale, we're talking about things that are equidistant from one another. And whenever I think of interval scales, I think about all the work that we do with guided reading and leveling texts. So here's an example of something of an interval scale, right? Particularly with Fontes and Pinnell's leveling system, it's considered that each of these intervals, A-level text, B-level text, C-level texts, are equidistant from one another, right? And they're alphabetic versus numerical, but there's an assumed absolute zero, an arbitrary absolute zero, which is the A or the pre-A, right? And that's not really an actual zero. If this were a true interval scale that represented reading development, it would start at literally the moment before birth, right? It's kind of almost like we can liken it to temperature, right? Where temperature actually has an arbitrary 0 point. Yes, there's 0 degrees, but when we're talking about an absolute zero is where there is absolutely no heat whatsoever. And even at, sorry, my dog is being loud. And so even when we're at 0 degrees, there's still some measure of heat, right? So it's not an absolute zero, that's an arbitrary zero. The same as when we have an arbitrary 0 and arbitrary A in relationship to guided reading levels. So let's move on. Let's move on to ratio intervals. So we had just talked about intervals that had an arbitrary 0. Ratio intervals have an absolute 0. So I have a timeline here, and there are, if we look at ages, age starts at 0, right? And then ends at 6, and we have child 1 and child 2. What this allows us to do, the presence of an absolute 0, being the day of birth, is it allows us to make ratios. And in this way, we're able to say child 2 is 3 times older than child 1. The ratio then is 3 to 1, right? And these are ratios that we can make here because there's an absolute 0 that we can't make in using other scales, right? This would be impossible using an interval scale because of the lack of an absolute 0, right? We don't know how that works in terms of creating ratios. So that's what these ratio intervals allow us to do. I do want to take a minute to have a quick aside and talk a little bit about Likert scales and items, because these are really popular survey constructs, but they're really kind of different in how they're being used. So when we're thinking about a Likert scale, we're not necessarily talking about the scale itself, like 1 to 5, or strongly agree, strongly disagree. Likert scales are actually constructs of several responses. They're the sum of several responses within a larger survey, right? So you have the substrata, so you have the questionnaire, for instance, and let's say every third survey question is part of the same Likert scale. Each of these questions, each third question, would ask questions, reiterations of the same kind of question to provide a sense of consistency and uniformity throughout that particular Likert scale, right? So you may have a Likert scale on pleasurable information text reading. In a survey of 15 questions, 5 of those questions would all deal with pleasurable information text reading, just worded and phrased differently. So you could look at that scale and see whether they are being consistent in their answers. Now, those scales are composed of individual Likert items, and now these are the statements that participants are asked to respond to. So several items make up a scale. If you'd like a bit more information about this, I have uploaded an article into the resources file. It is there for your perusal. Now, when we're talking about all this measurement, we want to make sure that we are being adequate in our measurement. How do we ensure that measurements allow us to arrive at the conclusions being asserted and what people are doing with these particular scales? This brings us to the notion of validity and reliability. And validity has to do with the notion of to what degree are researchers measuring what they claim to measure? Like, are they actually getting at what they say they're getting at? So let's say that someone is using a guided reading book series to talk about reading achievement in a first grade classroom. And one of the assertions that is made is that students who are in this classroom and engaged in small group guided reading groups versus whole groups are experiencing 3 times more the achievement than their individual reading peers. Because of the interval scale nature of guided reading, they can't make that claim. Their measure is invalid, right? The only way that they would be able to do that is to come up with a reading scale that had an absolute 0, and that isn't out there anywhere that I know of. We also want to make sure that we're paying attention to reliability, or the external and internal consistency of measurement. How is it that these scales are replicable, right? How reliable are they outside of the study at hand? And so whenever someone's using a scale, a survey, or an instrument of that type, you always want to pay attention to how reliable has it been outside of this particular survey? Was there a pilot study? If there was a pilot study, what were the results? What changes did they make, etc., etc., etc.? And that's how you build up reliability, the notion that the instrument gets at what it's meant to get at. So, in summary, measurement refers to the ways characteristics of a variable are represented numerically or symbolically, and this is often done utilizing a scale of some sort, including nominal, ordinal, interval, and ratio. And when thinking through measurement, we want to be concerned with issues of validity, and reliability. And I'm just going to combine them and call them reliability. It's going to be great. Quick thing that I want to mention before I leave you on this podcast. In terms of validity and reliability, they often go hand to hand, but one is not indicative of the other. So you always want to make sure that validity and reliability are addressed in some way separately. You want to be sure that they're not assuming because one is there that the other is as well. That's a shortcoming of their writing if it happens in an article. So with that concludes measurement.